Hello friends, welcome back to our online course on refrigeration and air conditioning. Let us start with the definitions, few of the definitions related to the psychrometric properties of air. The first definition is nothing but the dry air. The dry air is a mixture of number of gases which goes as nitrogen, oxygen, carbon monoxide, carbon dioxide, hydrogen, helium, and so many gases are there inside the atmospheric air. Now, this dry air actually it is not a present in the nature. What we are saying here, this dry air is absence of moisture, and practically it is not possible to have the absence of moisture. Then in all the applications, while calculating, what we are going to consider, we are going to consider air as an ideal gas, and that ideal gas is nothing but mixture of dry air plus water vapor, or we can say that water vapor as moisture. Now what is the moist air? Moist air is nothing but what? Mixture of dry air and water vapors. Then what is the definition of moisture? The amount of water vapors which are present in the air, these are nothing but the moisture. Now let us move towards the next definition, that is nothing but saturated air. Now the saturated air is nothing but a maximum amount of water vapors, or to these water vapors we can say it as a moisture. Maximum amount of water vapors or moisture which can be mixed with air. In order to understand the definition of saturated air, let us take an example. We have taken a room or compartment which is having a volume of 1 meter cube and which contains moist air, that is mixture of dry air and water vapors. And let us say that the water vapors present inside this 1 meter cube compartment are 5 grams only. Now in the next set of conditions, what I am going to do, I am going to add a few of the water vapors inside this 1 meter cube of compartment. Now maximum how much amount or how much quantity of water vapors will be added inside this 1 meter cube room capacity, that is nothing but saturated air. Now let us say that its volume is 1 meter cube, its pressure is 1 atmospheric pressure, and its temperature is 20 degrees Celsius. Now under these set of conditions, in this 1 meter cube compartment, how much quantity of water vapors I can add? I can add only 17.39 grams of water vapors inside the room. Now above this 17.39 grams of water vapors, above it, if you will add the water vapors inside this room or this compartment, what will happen? Those water vapors will be converted into dews, or what we can say that as a fog. Now you might have understood in the winter season why there is much more fog. Now here one table we have prepared, and this table shows that at which temperature in 1 meter cube of that room or compartment how many or how much grams of water vapors can be added. For 20 degrees Celsius temperature 17.39, similarly for 19 it is 16.25, up to for 12 degrees Celsius temperature how much is the maximum quantity of moisture need to be added, that is 10.69. And if I will pay the close attention to all these values, what I can find? As the temperature goes on decreasing, the amount of moisture which can be contained by this 1 meter cube of compartment goes on decreasing, except at 17 degrees Celsius. Now this you can take as a homework. What you need to do, you need to find out why at a 17 degrees Celsius, instead of decreasing the value of moisture content to be added, it goes on increasing. That you have to take as a homework. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.